The properties of limits. There are many fundamental properties of limits that enable one to simplify complex or unfamiliar limits into simpler or more familiar limits that can be calculated more easily. So if L, M, C, and K are real numbers, and the limit of f of x as x approaches c equals L, and the limit of g of x as x approaches c equals M, then we get some of these rules. So first we have the sum rule. So the limit of the sum of two functions is the sum of their limits. Essentially, the limit of the quantity f of x plus g of x is equal, as x approaches c, is equal to L plus M. So remember, L and M from this slide is the limit of f of x as x approaches c is L, and the limit of g of x as x approaches c is equal to M. So we can conclude that the limit of the quantity f of x plus g of x as x approaches c is equal to L plus M. Similarly, the limit of the difference of two functions is the difference of their limits. So the limit of the quantity f of x minus g of x as x approaches c is equal to L minus M. The product rule. The limit of a product of two functions is the product of their limits. So the limit of the quantity f of x times g of x as x approaches c is equal to L times M. Constant multiple rule. The limit of a constant times a function is the constant times the limit of the function. So the limit of k times f of x as x approaches c is equal to k times L. Quotient rule. The limit of a quotient of two functions is the quotient of their limits, provided the limit of the denominator does not equal 0. So the limit of f of x divided by g of x as x approaches c is equal to L divided by M, or the limit of f of x divided by g of x as x approaches c is equal to the limit of f of x as x approaches c divided by the limit of g of x as x approaches c, where M can obviously not equal 0. The power rule. The limit of a rational power of a function is that power of the limit of the function, provided the latter is a real number. So the limit of f of x to the power r divided by s as x approaches c is equal to L to the power r divided by s. Limit of a constant. The limit of a constant is the constant. So the limit of k as x approaches c is k. And the limit of a variable. The limit of the variable is the limit. So the limit of x as x approaches c is c, the limit. Here's an example. So write each limit in a different form using the limit rules. Okay, so the limit of x squared plus 3 as x approaches 4. We can rewrite this as the limit of x squared as x approaches 4 plus the limit of 3 as x approaches 4. The limit of x squared minus 3 as x approaches 4 can be rewritten as the limit of x squared as x approaches 4 minus the limit of 3 as x approaches 4. The limit of 4x squared as x approaches 4 can be rewritten as the limit of 4 as x approaches 4 times the limit of x squared as x approaches 4. And the limit of 4x squared as x approaches 4, same as this one, however we can rewrite it differently. The limit, we can rewrite it as 4 times the limit of x squared as x approaches 4. So this is just fascinating, how you can write two limits in different ways. And this is because of this, I'll get a different color, but this bit right here, because we know from one of the rules that the limit of 4 as x approaches 4 is 4. So what we essentially have here, the blue comes out to 4 times the limit of x squared as x approaches 4. And now we can see how they're exactly the same. So the product rule and the constant multiple rule can end up being the same thing if one of the two functions is a constant. Okay, the limit of the quantity x plus 4 divided by the quantity 3x minus 5 as x approaches 1 can be rewritten as the limit of x plus 4 as x approaches 1 divided by limit of 3x minus 5 as x approaches 1. The limit of x squared as x approaches 4, limit of x as x approaches 4, that quantity squared. The limit of 4 as x approaches 2 can be simply rewritten as 4. And the limit of x as x approaches 2, the limit of a variable, is the limit with 2.